Security, identity, and access management. When we talk about cloud security, we like to start with a discussion of the shared responsibility model. Although AWS takes care of provisioning and maintaining the underlying cloud infrastructure, you will still need to perform several security configuration tasks to ensure that you stay safe in the cloud. The responsibility of AWS goes from the ground up to the hypervisor. AWS secures the hardware, software, facilities, and networks that run all products and services. Customers are responsible for securely configuring the services they sign up for and the data they put in those services. AWS also performs the following responsibilities: obtaining industry certifications and independent third-party attestations, publishing information about AWS security and control practices in white papers and website content, providing certificates, reports, and other documentation directly to AWS customers under NDA as required. The amount of security configuration work you have to do varies depending on how sensitive your data is and which services you select. For example, AWS services such as Amazon EC2 and Amazon S3 are completely under your control and require you to perform all the necessary security configuration and management tasks. In the case of Amazon EC2, you are responsible for the management of the guest OS, including updates and security patches, any application software or utilities you install on those instances, and the configuration of the AWS provided firewall, called a security group, on each instance. When you use any of the AWS managed services such as Amazon RDS, Amazon Redshift, or Amazon WorkDocs, you don't have to worry about launching and maintaining instances or patching the guest OS or applications. AWS handles that for you. For these managed services, basic security configuration tasks such as data backups, database replication, and firewall configuration happen automatically. However, there are certain security features such as IAM user accounts and credentials, SSL for data transmission, and user activity logging that you should configure no matter which service of AWS you use. AWS support provides a highly personalized level of service for customers seeking additional technical help. One of the main security responsibilities of AWS is the physical security of the data centers that house the AWS cloud infrastructure. Amazon has many years of experience designing, constructing, and rating large-scale data centers. The physical security measures that protect these data centers are some of the most comprehensive in the industry, include 24/7 trained security guards, locations in nondescript, undisclosed facilities, two-factor authentication for ingress, authorization for data center access only for approved, specific need, and continuous monitoring, logging, and auditing of physical access controls. The hardware and software that supports AWS cloud services has been architected to be highly available, redundant, and extremely secure. All changes to AWS hardware and software are managed through a central, automated change control process, and all access to hardware or software must be authorized. Privileged access to software and systems require SSH login and is allowed only through Bastion servers that record all access attempts. AWS network devices, including firewall and other boundary devices, monitor and control communications at the external boundary of the network and at key internal boundaries. AWS monitoring tools are designed to detect unusual or unauthorized activities and conditions at egress and ingress communication points. These tools monitor server network usage, port scanning activities, application usage, and unauthorized intrusion attempts. AWS security monitoring tools help identify types of denial of service attacks, including distributed, flooding, and software logic attacks. AWS has successfully completed multiple audits, attestations, and certifications. AWS publishes a Service Organization Controls SOC 1 report published under both the SSAE 16 and the ISAE 3402 professional standards as SOC 2 Security and SOC 3 report. In addition, AWS has achieved ISO 9001 ISO 27001, ISO 27017, and ISO 27018 certifications, and has successfully validated as a Level 1 service provider under the Payment Card Industry PCI Data Security Standards DSS, and currently offers HIPAA business associate agreements to covered entities and their business associates subject to HIPAA. In the realm of public sector certifications, AWS has achieved FedRAMP compliance, has received authorization from the U.S. General Services Administration to operate at the FISMA moderate level, and is also the platform for applications with authorities to operate ATO under the Defense Information Assurance Certification and Accreditation Program, DIA-CAP, NIST FIPS 140-2, CJIS, and DoD SRG Levels 2 and 4 are some of the other certifications AWS has received. AWS provides customer access points, also called API endpoints, that allow HTTPS access so that you can establish secure communication sessions with your AWS services, including SSL and TLS. SSL encrypts the transmission, protecting each request or response from being viewed in transit. AWS also provides security groups which act like built-in firewalls for your virtual servers. You can control how accessible your instances are by configuring security group rules, from totally public to completely private or somewhere in between. When your instances reside within a virtual private cloud subnet, you can control egress as well as ingress traffic. Security groups can also be used by AWS services such as Amazon RDS, Amazon Redshift, Amazon EMR, and Amazon Elasticache. You can set up security rules for your EC2 instances to create a traditional multi-tiered web architecture. The web tier security group can accept traffic on port 80/443 from anywhere on the internet if you select 0000/0, the internet. Alternatively, it might make more sense to accept only traffic from a load balancer so that individual clients cannot overload a single server and the load balancer can perform its job. Similarly, the app tier can only accept traffic from the web tier, and the DB tier can only accept traffic from the app tier. Lastly, we have also added a set of rules to allow remote administration over SSH port 22. We've restricted the remote access by funneling all traffic through the app tier and allowing only access from a specific IP. After you use SSH to access an app tier server, you can then connect to the machines on the web and DB security groups. The Amazon VPC, Virtual Private Cloud Service, allows you to add another layer of network security to your instances by creating private subnets and even adding an IPsec VPN tunnel between your network and your VPC. Amazon VPC allows you to define your own network topology, including definitions for subnets, network access control lists, internet gateways, routing tables, and virtual private gateways. The subnets that you create can be defined as either public or private. Identity and access management. Using AWS IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. You can use existing corporate identities to grant secure access to AWS resources, such as Amazon S3 buckets, without creating any new AWS identities. All AWS services and resources can be accessed using the AWS Management Console, AWS CLI, or through SDKs and APIs from a wide range of supported platforms. Users and systems have to be authenticated before they can access AWS services and resources. The AWS Management Console provides a web-based way to administer AWS resources. If you're the account owner, you can sign into the console directly using the root account. It is, however, advisable to create an individual IAM user for each person and sign in using individual credentials. IAM is a complementary service. The AWS command line interface is a unified tool to manage your AWS services. With AWS CLI, you can control multiple AWS services from the command line and automate them through scripts. AWS CLI is supported on Windows, Linux, OS X, and Unix platforms. AWS offers support for a wide variety of programming platforms, including .NET, Java, and Python. As the number of users managing your AWS environment increases, it is helpful to manage permissions for multiple IAM users using IAM groups. After a user or system has been authenticated, they have to be authorized to access AWS services. To assign permissions to a user, group, role, or resource, you create a policy, which is a document that explicitly lists permissions. An IAM role is similar to a user in that it is an AWS identity with permissions policies that determine what the identity can and cannot do. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Also, a role does not have any credentials, password, or access keys associated with it. Instead, if a user is assigned a role, access keys are created dynamically and provided to the user. Policies are documents that are created using JavaScript Object Notation, or JSON. A policy consists of one or more statements, each of which describes the set of permissions. IAM policies are assigned to IAM users and groups. These users are bound by the permissions defined in the IAM policy. IAM policies may also be assigned to an IAM role. An IAM role is similar to a user in that it is an AWS identity with permission policies that determine what the identity can and cannot do in AWS. A role does not have any credentials, password, or access keys associated with it. Instead, if a user is assigned to a role, access keys are created dynamically and provided to that user. You can use roles to delegate access to users, applications, or services that don't normally have access to your AWS resources. For example, if a custom application is written within Python and hosted on an Amazon EC2 instance, and it needs to interact with objects stored in an Amazon S3 bucket, applications may access AWS resources in multiple ways. One way would be to embed your AWS access key and secret access key in the application code or config file supported by the application. The question is that a good idea? No. Doing so may compromise the user's credentials. Changing or rotating the user's credentials would require an update to the code each time. This approach is also not secure and feasible in many cases. Anybody put their credentials in GitHub recently? Bad idea. Instead, the alternative and secure option is to use an IAM role to pass a temporary security credential as part of an instance profile. An instance profile is a container for an IAM role that you can use to pass role information to an EC2 instance when the instance starts. In an example, an IAM role named Python in EC2 Access S3 is created by an IAM user. The role grants access to an Amazon S3 bucket. An application developer selects the Python in EC2 Access S3 role when creating the Amazon EC2 instance. This instance will host the Python application that needs access to the bucket. Note, an IAM role may be associated with an EC2 instance only during creation. The policy associated with the role can be modified at any time. A user launching the EC2 instance also needs appropriate permissions to associate an IAM role to the EC2 instance. The Python application is installed on the EC2 instance. AWS SDK for Python, Boto 3, is also installed on that instance. The application tries to access the Amazon S3 bucket. However, credentials are not available on the instance. The Python uses the EC2 metadata service to gain access to temporary security credentials. The application interacts with the S3 bucket specified in the Python in EC2 Access S3 role. IAM roles may also be associated with users. In this example, there are two AWS accounts, A and B. IAM user A1 is part of account A, and IAM user B1 is part of account B. An IAM policy named IAM admin policy with access to an Amazon S3 bucket is associated to an IAM role named IAM admin role. User A1 has an IAM policy with restricted access. This is done because user A1 does not normally need admin privilege. However, user A1 may sometimes have to perform tasks that require admin privilege. When required, user A1 assumes the IAM admin role. Doing so gives user A1 access to the S3 bucket. A user who assumes a role temporarily gives up his or her own permissions and instead takes on the permissions of the role. When the user exits or stops using the role, the original user permissions are restored. It is therefore helpful to use IAM roles instead of changing users' policies each time a change is required. User A1's policy must contain permissions to assume the role, and user A1 gains access to the Amazon S3 bucket. With IAM roles, you can establish a trust relationship between you and a trusting account and other AWS trusted accounts. The trusting owner or the trusting account owns the resources to be accessed, and the trusted account contains the users who need access to the resource. User B1 from account B assumes the IAM admin role from account A. User B1 gains access to the Amazon S3 bucket owned by account A. AWS Security Token Service, AWS STS, provides trusted users with temporary security credentials that can control access to your AWS resources. These credentials are short-term and work almost identically to the long-term access key credentials. These credentials are generated dynamically and are provided to the user when requested. A session established with an AWS STS consists of an access key ID, secret access key, a session token, and expiration time. The expiration time could be between 15 minutes and 36 hours. The keys are used to sign API requests and pass a token as an additional parameter, which AWS uses to verify the temporary access keys are valid. AWS IAM is not appropriate for operating system and application authentication. It is only for access to AWS resources. AWS IAM authentication and authorization is a powerful service to authenticate and authorize users and AWS resources. It is a best practice to not use your root access keys. Therefore, delete them. AWS root account access is explicitly allowed and cannot be taken away. So create individual IAM users, use groups to assign permissions to those users, grant least privilege for operating, and have a strong password policy that includes multi-factor authentication. It is also good to use roles for applications. Do not embed credentials in your code. Use roles instead of sharing credentials and rotate their credentials regularly. Remove unnecessary users and credentials. If somebody leaves, have an audit policy to track when they're hired and when they are leaving your organization. Use policy conditions for extra security and monitor activity in your AWS account. AWS CloudTrail is a web service that records API calls to supported AWS services in your account and delivers log files to you.